Hello and welcome back to Petals for Your Troubles Physics. My name is Chris and today we'll be dealing with a problem that tackles rotational kinematics, rotational motion, and angular displacement. As usual, feel free to pause the video at any time to try out answering these things on your own. Again, after reading the question carefully, we'll be writing down what's given, writing down what's asked, writing up our solutions, and then boxing our final answer, aka the GASA method. Now let's read our question. The blades of an electric blender are whirling with an angular velocity of 375 rads per second while the puree button is pushed in. When the blend button is pressed, the blades accelerate and reach a greater angular velocity after the blades have rotated after 0.095978 seconds. The angular acceleration has constant value of 1740 rads per second squared. Find the final angular velocity of the blades. Now let's write down our given. We are given three variables: the initial angular velocity, which is 375 rads per second, the time, which is 0.095978 seconds, and the angular acceleration, which is 1740 rads per second squared. We are asked to find the final angular velocity. But before we can do that, we need to find the angular displacement, which we can do by using the formula initial angular velocity times time plus the angular acceleration times time squared over 2. This gives us an answer of 44, which then leads us to our next equation. Now we can find the final angular velocity with the equation final angular velocity squared is equal to the initial velocity squared plus 2 times the angular acceleration times the angular displacement. This gives us an answer of 293,745, which when squared will give us a final angular velocity of 542 rads per second. And that's pretty much it for this episode of Petals for Your Troubles Physics. If you like the content, maybe leave a like and maybe subscribe. Thank you for your time. We hope you enjoyed this video and we hope you learned something.